Hello student. So let's see the next stage of decision tree, that is decision table. Now here either you can use or draw decision table after a tree, or you can draw a table before the tree. So it is up to you, how do you understand. So, and I hope so you all have done the assignments. So let's see further decision table. I am Dr. Alifia Jhakidar, Assistant Professor of Abid Ananda Senior College. Let's go ahead. Now what is a decision table? It is a method of describing the complex relationship in precise manner which is easily understood. Okay. It is useful in situations where the resulting actions depend on the occurrence of one or several combination of independent conditions. It is a matrix containing row or columns for defining a problem and action. So your decision table, the word itself says that it is a table, and table is nothing but combinations of rows and columns, and decision is written into the table, which gives a broader view to the customer or developer to understand what decision have to be taken. Now there are components of decision table. So it is divided into 4 components. One is condition stub, other is action stub, condition entry and action entry. So let's see with the diagram. This is divided into 4 quadrants, you can say. So first, left side quadrant or upper left quadrant. See, this is a quadrant, okay? This is the quadrant. So here this is called as upper left quadrant, which is called as condition stub. And here the conditions are written, okay, which has to be checked. So in this particular quadrant or section, the conditions are written which has to be checked. The next quadrant is this. This is lower left quadrant. So this is left side and this is right side. This is upper left, this is lower left. So this is action stub, which says which gives the outline of all the actions to be carried out to meet the conditions. Okay, so these are the conditions which has to be checked, and these are the actions which has to be carried out. Now come to the right hand side. So this is the right quadrant, upper right quadrant and lower right quadrant. This is called as condition entry, which I have written as CE for your better understanding, better remembrance. It is going to provide an answer to the question. If I ask a question here, this is going to provide me the answer. Like condition, if it rains, then what will happen? You will stay at home. So this is giving me the condition answers. Like in the and the next is action. It is in the lower right quadrant, which will indicate the appropriate actions. So here, if it rains, then what will happen? You will stay at home, and here you are going to stay in the house. So that is called as action entry, which is going to give me the answers to the appropriate actions and to the conditions in the condition entry quadrants. Okay, so here let's read it out. It is the upper left quadrant which will list all the conditions to be checked. Action stub, it is the lower left quadrant which outlines all the actions to be carried out to meet the conditions. Condition entry, it is the upper right quadrant which will provide answer to questions asked in condition stub quadrant. Action entry is the lower right quadrant which will indicate appropriate action resulting from the answer to the conditions in the condition entry quadrants. Okay, so let's see ahead. The entries in the decision tables are basically given by decision rules, which will define the relationship between the combination of conditions and actions. Y shows the existence of a condition. N represents condition which is not satisfied. A blank against action states it has to be ignored. Okay, you don't write cross for ignorance of the action, but you have to keep it as blank. Okay, always keep in mind this particular point. X or check mark will do against action state is to be carried out. You can either use a check mark or a cross for saying that this action have to be considered. Now let's see this in example. As I said, it is divided into quadrants, 4 quadrants. So this is condition stub and the conditions written here. These are the actions. Okay, so this is divided into conditions again, and this is where the actions are taken. Okay, so let's see with this. Advance made payment made, this is first condition, then what rule should be applied? Purchase amount is greater than equal to 10,000, what rule? If it is a regular customer, then what rule? Actions, what happens on the condition is give 5% discount, give no discount. Before going to a problematic problem, let's see here with the condition, with the decision table, can I do it properly? Can I get the insight? So let's go ahead. So rule says advance payment done, yes. Ignore the purchase of 10,000, ignore the regular customer, give 5% discount straight away. Second rule can be advance payment done, no, but the purchase amount is equal to 10,000, it is a regular customer, then give 5% discount. The third rule will be advance payment made, no, purchase amount is yes equal to 10,000 but not a regular customer, no need to give the discount. Rule 4, no advance payment, no purchase amount equal to 10,000, it is not a regular customer, matlab ignore this action and then ignore this condition, sorry, but the action is give no discount. So these are the rules and conditions, and if you see it without reading the problem, we have identified the decision table and identified the actions and conditions. So this is very easy to understand and view the things. Okay, let's go ahead. Let's take an example again for scenario 1 for an ATM. Okay, now ATM says that a customer is requesting a cash withdrawal. One of the business rules for the ATM is that ATM machine pays out the amount if the customer has sufficient fund in their account. Okay, if the customer has the credit granted or the credit is granted already. This simple example of business rule is quite complicated to describe in text. It is very difficult in text. Sometimes we may miss any of the conditions or queries. Okay, so your decision table is going to help me to do it. So now conditions, how many rules? First rule is if it is having sufficient amount, then withdraw the amount. Second, if it does not, if it has a credit granted, then we'll allow the withdrawal, else no withdrawal done. Simple 3 rules we are going to use. Conditions where withdrawal amount is less than equal to balance amount, this is where your fund has to be maintained, or a credit is granted already, this is the condition. Action is withdrawal granted is one single action. Okay, let's go here. Rule 1, rule 2, rule 3. So withdrawal amount is less than equal to balance, it's true, either write you write X or you write tick. Then what will happen? What will be the action? Withdrawal is granted. If rule 2, just check, the balance is less, the withdrawal amount is greater than the balance. Okay, so it does not satisfy this condition, but the credit is granted, so I am going to give access for withdrawal. But if both the conditions are false, then I won't allow the withdrawal. So this is how the decision table is made. Clear? Let's go ahead. How to make decision based table for login screen? Let's go for login screen now. Now in login screen it says that if my username is correct, password is correct, show me the home screen. Okay, if my username is correct and my password is wrong, it should display the error message that my password is wrong. Vice versa, if my username is wrong and password is correct, it should give me error as password is wrong or username is wrong, vice versa. Else it should exit the page. Okay, so currently here we are just going to display the error message. So let's see this. The rules are, if it is true, then correct username or password. False if wrong username or wrong password, both can be false. Error message is displayed if both are, if any of them is false. Okay, H is your home screen is displayed. You can write this or you can just draw or leave it as ignorance. It all depends on you. Let's come here. Case 1. Username and password both were wrong. Error message is displayed. First case. Case 2. Username was correct but password was wrong. Again error message. Case 3. Username was wrong but password is correct. Again error message. If both the things are correct, then user is navigated to home page. So let's draw the table. Please remember the columns have to be your rule numbers, okay, and the rows have to be conditions and your action. Now here I have written as output, you can write it as an action over here. So here username true or false because they had told it before in rule 1. password true or false, and output is either error or home page. So E is for error and H is for home screen. Okay, I'll write it down for you all if you want. Oh, okay. Okay, let's go ahead with it. Arrow. Okay. So now here I have drawn the table. These are the rules 1, rule 2, rule 3, rule 4. I have written username, password and output. Okay. If rule 1, if username is false, that means not correct. My password is not correct. That means I'm going to display E, that is error. Rule 2, if username is correct but password is wrong, then again error. Rule 3 says username is wrong, password is correct, then again I get error message. And rule 4 is here, it is both are correct, so I will navigate to home page. So you should remember this, how you have to draw. So you have to just read the rules and put it down into your decision table. Next example of decision table is, here in this table there are multiple rules for single decision. Okay, but there are rules from a decision table can be made by just putting an and condition to it. Like if it is a working day and it is not an holiday and it is also raining, then you can go to office. But if it is let's read it here. R1, the first rule says, if it is a working day, yes, and it is an holiday, it is not an holiday, sorry, and it is raining, still you have to go to office. Rule 2 is, if it is a working day, it is not a working day, it is not an holiday, it is not raining, then also go to office. If it is not a working day, it's an holiday, it's a rainy day, then watch a TV in the house. If it is not a working day but it is raining, it is on holiday and it is not raining, then go to picnic. Okay, now these rules can be optimized. Like how? First, optimize R1, like I am optimizing this. If it is a working day, then go to office. If it is a working day, then go to office. Or if it is not an holiday, then go to office. So I have written either this, either this. Okay, then go to office. Optimize your R3. Here R3 it says, if working day is N, that is no, and it is raining, then watch TV. Or if it is an holiday, it is raining, then also watch TV. So I am optimizing. Okay, not necessary, you can directly draw the decision table. Okay, if you don't want to optimize it. Optimize R4, if it is working day, no, it is raining, no, then go to picnic. Here. If it is an holiday, it's not raining, then also go to picnic. Okay. One advantages of decision table is that you can make it possible to detect combination of conditions that would otherwise not have been found and therefore not tested or developed. The requirements become much clearer and you can often realize that some requirements are illogical. So something that is hard to see when the requirements are only expressed in text. Disadvantages: decision table is not equivalent to complete test case containing step-by-step instructions of what to do in what order. Then when this level of detail is required, decision table has to be further detailed into test case. Only decision table does not give you the complete answer. There has to be certain test cases which has to be run onto your system to get the desired answers. Okay. The following rules are constructed from the decision tree as shown. If day is equal to working and outlook is raining, then go to office, as I just shown you all with the optimization. But here the same, if R1 and R2, there is no need to check the condition for R1 and R2, because if it is working and whatever it is, either it is rainy or sunny, you have to go for job to the office, right? Only here you have to check with the condition. So what it says, R1, R2, there is no need to check the condition. If outlook, like it is either rainy or sunny and day is working, because if the day is working, whether it is sunny or rainy, the decision is you have to go to the office. So the following rules can be optimized to version of R1 and R2. Like R1 is optimized, if day is equal to working, then go to office. If R2 is optimized, if day is equal to working, then go to office. The refinement of optimization is effective, efficient and accurate result it is going to give me, right? Now conversion of decision table into tree, as I just told you at the start, you can convert table to tree and vice versa. Data can be transformed from table to tree. The decision table can be converted into decision tree by using conversion method. The resultant tree has two categories, balanced tree and unbalanced tree. Okay, so this is decision table transformation and decision tree. Thank you so much for listening to the videos. I hope so you'll have understood with the decision table and the decision tree. Please try out the same assignment of decision tree. Try to draw the decision table for the same question. Thank you so much.